Okay, we're going to continue with polynomials. If I get cut off in this video, I'll just pick up the next video where this one ends because we kind of have, quite a few things to get through. Okay, remainder theorem. All right, so first of all, if I sub in input, right, this is my input, so I'm going to sub it in. And I want to get output, right? So I have what, 27 minus, what is that? 9 times 4 is 36. Minus 5. All right, so what do I end up getting there? Negative 14. Okay. And again, you could just type that in a calculator. As long as you set it up right, you're good. So anytime someone gives you input, it's always a good idea to, sub it into your function, see what your output is. Okay. So what this means is I know the point 3, negative 4 is on this polynomial function. Okay. I also kind of know how this behaves, right? It's an odd power. So end behavior is this. I know it can have at most 2 changes in direction. So this is just a dot, dot, dot. That's not the actual graph. So I know quite a bit about this. I know if I sub in 0, my y-axis is a negative 3. I can figure some things out about this. Okay. What does the remainder theorem says? The remainder theorem says is kind of cool. Basically, it's saying that let's pretend this is a factor. Okay, because remember how answers and factors are backwards. All right, I'm going to say is, x minus 3 a factor of that? Okay, now you might be like, okay, how do I do it? It's a cubed with a squared. There's not 4 of them. I can't do factoring by grouping. I'm kind of at a loss what to do. Okay, so what we're going to do to see if it's a factor is we are going to divide it. Kind of like if someone says, hey, 24 is 2 a factor. When you're a little kid, you would divide and be like, oh, yes, it is. Because when I subtract, help us if I write the right number, I get a remainder of 0. So it is a factor. Where, say, 7 goes into 24 and you're like, ooh, 3 times is 21. But notice I get a remainder, right? Okay, when I divide, I get a remainder of 3. And so 7 is not a factor of 24. So you divide to see if something is, a nice factor. So we're going to do long division. I'll show you synthetic division as well. So we're going to kind of hit some of these while we're at it. So I'm going to write this as a kind of like a number, like x cubed and then minus 4x squared. And then I have 0 x's. So I need a place value holder for that. And then what? Minus 5. Okay. Hopefully you see the similarities between, like, say if I had a 3-digit number, what, 1, 4, I don't know, say 0, 5. So say I'm dividing 1,405 by 13. I would write the digits, and that's exactly what I'm doing in algebra. So the long division you did as a kid is the same long division you did here. Now, the problem is some of you are like, Julie, I forgot how to do long division of normal numbers, and you're trying to have me do it in algebra. Okay, that is a problem. So let's just review a little bit. Say, and I'm not going to pick, a terrible example here, but long division. Remember, you would say, ooh, does 8 go into 3? No, it does not. So you'd slide over. Does 8 go into 30? And you'd be like, 8 times 4 is 32. I think I'll try 3. And you write it above that place value. 8 times 3 is 24. You would subtract and get 6. And then remember how you'd bring down the 8. Okay. Then you'd be like, ooh, does 8 go into 68? And you would say, yes, it does, 64 times. And you would get a remainder of 4. So it'd be remainder 4, okay? Now, what you're really doing here, again, you might not see it, so I'll kind of write it out. This is really 300 plus 0 tens plus 8, right? I mean, that's kind of, I'll write that as a double digit. Okay, so when you put the 3 above here, you're really saying, oh, that's 30. That's the tens unit, right? So you're really taking, 30, so to speak, times that. So 30, that's where that 240 comes from. And notice I'm going to write it 240 like that. Notice when we subtract the 2 and the 4, right? Like if I ungroup, I'm subtracting the 2 and the 4 because I'm really subtracting all of the 24, okay? And so, that's kind of how that comes about. So really, if I take 100 minus 40 plus 8, that's 60. Oh, did I mess up here? 68. No, that combines to 68, which I'm going to write it 68. I'm going to put the 60 and the tens in here. So then when we put the 8, that's really 8 ones, right? And so you take 8 times 8 and you get 64. Notice you're really subtracting the 60 and the 4. I'm going to subtract the 60 and I subtract the 4 and I get my remainder of 4. That's kind of what's happening behind the scenes. Okay, so we want to view this from an algebra lens. All right, so first of all, the goal is step number 1, you want to match. I want the powers to be the same. This is x cubed, this is x. I need x squared. And do you see how I'm going to write it above the x squared? Kind of like I didn't have any hundreds, but I had tens, so I put it above the tens. Here, in a sense, it's like we have hundreds, so we want to put there. So the step number 1 is match this exactly. Step 1, match. Okay, step 1, you want to match. Step 2, you distribute or you multiply, right? That's what I do here. I took the 3 times the 8, and if it had 2 parts, I'd distribute it. So I'm going to distribute. So I get x cubed and negative 3x squared. The next step is you subtract, but you subtract all of it, right? Like down here, I subtract all of it. I subtract all of it. So in algebra, when you subtract all of it, you distribute it, which means you opposite things. So I'm going to subtract this, which makes it negative, and subtract this, which turns it into positive. And then the next step is you bring down. Okay, now the nice thing is in algebra, these will always cancel because you're forcing them to match. Okay, so distribute. Step 3 is do the opposite, and step 4 is bring down. And then you just keep rotating and rotating until you're done. All right, so what do I have here? A negative and a positive, I O x squared. And then I'm just going to bring it all down because algebra is just a tad different. Okay, so now I want to match exactly, okay? I have an x, I need negative x squared. So I need a negative x. And do you see why I need that 0? Because I need that place value for that. Kind of like if you have a 0 in math, right? Like here, you have to write the 0 because it has to hold that place value. So negative makes it match. Okay, so now distribute. So I'm going to take that times both, distributive property, negative x squared and a positive 3x. Okay, and then now I'm going to make them opposite because I'm subtracting. So this becomes positive, this becomes negative. And then step number, I made them opposite. Now I'm going to bring down. These should cancel. That's a negative 3x minus 5. I'm kind of running out of space here. I want to match exactly. So I need what? A negative 3. And let me cross that off here. I'm going to distribute negative 3x and what? Positive 9. Opposite, positive, and negative, and I get a negative 14 as my remainder. All right. I kind of ran out of space here. So I'm going to rewrite this answer. So I took what? I did x cubed minus 4x squared plus 0x minus 5. I divide by x minus 3. That's a 4. And my final answer was x squared minus x minus 3. Now, the remainder, we usually write it as like, say, plus a negative 4 divided by the divisor. So x minus 3. Okay, so this is my answer. All right, and there's this cool thing that happens. See that negative 14, the remainder? That's the same answer we got here. So the remainder theorem says, hey, if you want to find the output, sub 3 into your function, get your output. But if you want to do long division, your remainder will also be your output, okay? Either way, it doesn't matter. And sometimes it's easier, and this is not easier, so I get it, but synthetic division isn't too bad, okay? So let me show you synthetic division so that you know what that looks like. All right, so we're going to flip the page. I'll do the same problem with synthetic division. So what did we have? All right, so we had x cubed minus 4x squared, what, minus 5. Okay, in synthetic division, all you do is the coefficients. So there's a 1, a negative 4. Now, notice again, there's 0 x's. So you need a coefficient of 0 and then minus 5. And these are place values, right? Like thousands, hundreds, tens, ones in a weird way. Okay, and we're going to take this, and what we want to do is divide by what? X minus 3. Okay. So what we do though is we don't put the factor here like long division. We put the 0. Like if this actually crossed on the x-axis, like the shift, the answer would be 3. Okay, so we're going to put that here. Okay, so then what do? We bring this down. So you always want to get in the habit of starting an arrow, bring it down. All right, and then you multiply. 3 times 1 is 3, and you add, bring down. So that's a negative 1. Multiply. -3 and add. And again, when I say add, we're adding integers. So, you know, it could be debt and debt makes more debt, money and money makes more money, one of each, maybe you have debt left over, maybe money. All right, and then 3 times a -3 is a -9, and bring down, and I get a -14. Okay, so how do I know my answer as far as that it matches what I got before? Well, if you divide by an x, okay, the power is going to go down. So this was x cubed. So when I divide, this is now x squared. This is x. That's my constant. This is my remainder. All right. So my answer is x squared minus x minus 3 plus a -14. Now my divisor is the factor that goes, or the binomial that goes with that, right? The factor, so be that. But again, this is a fast way to figure out what f of 3 is. Okay. That's not too bad. Okay. All right. So what's special about this? Well, if this is 0, that means you don't have a remainder, which means it divides into it perfectly. All right, so what does that tell me about the polynomial? That tells me it's a 0. So if I were to divide, and I have a polynomial, right, which is kind of one of these nice little curvy guys, these are all your zeros, your roots, your answers, your solutions. If you do synthetic division or long division, and you get a remainder of 0, then you know it is an answer. That f of whatever that value is an output of 0. That means that you have just found an x-intercept. Okay. All right. So let's try that. Let's see if I can find one here that would work. All right. So let me pause it for a second. I'll get started on that. Let's do another ugly long division first, and then we'll come back to that because I want to talk about when you can use synthetic division and when you can't. So let's do that first. Okay, this is an example of a problem that you can do with long division, but absolutely cannot do with synthetic division. Couple reasons. Number one, there's a squared in there. We can only do synthetic division with binomials that are like x plus 3, x minus 3, x plus 5, x minus 5. The other issue is there's a coefficient there, a 2. Can't do that either when synthetic division. So with synthetic division, it really has to be like things that would be zeros or factors. So they have to be pretty ones. They can't have any squared, cubed, or anything in them, and also cannot have a coefficient on the x. Okay. So this one you have to do long division. So let's practice again, just because long division is a problem. We have 0 cubes. Then we have x squared, then x's, then ones. And again, it's like place values: 4th power, 3rd power, 2nd power, 1st power, and constant. And we're dividing by this. And in long division, you do what they tell you to do. Okay. All right. First, you want to match. All right. So we want to match just our leading coefficients. All right. I need to get x to the 4th. I have this. Okay, so I need an x squared, which is great. But I need the 2 to go away. So I need a half, because a half times 2 is 1, and then I get my x to the 4th. So that's good. All right, so step number 1, I did. Match. Step number 2, distributive property. Okay, so you're going to distribute this to both. And again, if it doesn't match, you're wrong. So I distribute, and then plus I get what? Half x squared. See how you need to write it above the correct or under the right spot here, because it's an x squared, it's not an x cubed. Okay, step number 3, opposite, because you're really subtracting. This is going to be negative, and so is this guy, negative. Next step is bring down. Okay, so technically we're subtracting here. These go away. Ooh, that's a 0, that goes away. All right, what do I get here? I get a -3.5. Usually we probably do improper fractions, so I'd probably do what, 6/7 halves, -7 halves, x squared. Okay, you could do a decimal if you want to. All right, bring everything else down. All right, now we want to match again. And again, you're like, oh, Julie, this is not pretty. Okay, I want to get the -7, so in the numerator, so let's stick, and this is, I already have the x squared, so do you see I'm already down here? So -7, so that would give me that. Now I want to cancel the 2, but I also want to have another 2 down here. So I would need a denominator of 2 just to cancel it, but I want to get that, so I actually need a denominator of 4. I need 2 to cancel that, another 2 to cancel that. 2 times 2 is 4. But otherwise, I have the x squared. All right. Okay, so I got that. All right, so I match, check. Now the distributive property. So distribute, I get a -7 halves. It should match, otherwise we're wrong. And then distribute to this guy, I get a -7/4. Okay, great, distribute them. Opposite, this guy's negative, positive, and that goes to positive. All right, bring down.